Premium stuff. Okay, so rotational transformations is what we're looking at today. So we've already looked at when we're reflecting. We've looked at when we're translating. Reflecting is when we're like looking in a mirror. Translating is when we've moved it across. Rotation is where we're turning it. Okay, so in primary school we used to call this turn or spin. Yeah, that's right. Okay, so rotation is an isometric transformation. What does isometric mean?
Something. It's symmetric.
It doesn't change its size or shape. You're moving it, but it's staying the same size. It's around a point by some sort of given angle. So you can rotate at 90 degrees, 120 degrees, you can rotate at a full circle. You can go clockwise or anti-clockwise. Now, when you're rotating, there's a special thing called rotational symmetry.
What does that mean?
Rotational symmetry is when you rotate the shape, you go put a dot in the center of the shape, and as you spin it, if it produces an exact copy of the original before you've gone a full circle, you count every time that happens. Every time that happens, okay, you count how many times it happens, and it gives you the order of rotational symmetry. So, for example, a circle, doesn't matter how much I spin it, it's always going to look exactly the same. So it has infinite rotational symmetry. Okay, whereas other shapes, doesn't matter where I spin it, it's not going to look the same until I get back to the beginning. So it would have an order of rotational symmetry just 1. So let's look at 2 examples. Have we got that sentence down?
Yeah. No.
Hurry up,
first paragraph.
people.
Can I see yours?
Bunch of plebs. That wasn't rude. He's a very nice person.
Okay, if you haven't got it down, you can copy off the person next to you.
I've already done the first, but I need the second.
I'll come back to that in a second then, okay? Alright, so I've got 2 shapes here. First one is what? What's this?
Triangle.
Square. It's an oval.
What sort of triangle?
Oh. Isosceles triangle.
Equilateral.
Equilateral triangle.
Thank you, Callum.
Nailed it.
It's an equilateral triangle. Now, if I'm looking at this equilateral triangle,
Wait for it.
why is it not working?
Because it's broken.
Okay, so here's my equilateral triangle.
Yes.
Can you see the
times.
point straight up?
Yes.
I'm gonna, we're going to spin it a full circle, and we need to see how many times we get a triangle looking exactly like this.
3 times.
Okay, so there's 1,
1, 2,
3.
Okay, so it has
4.
rotational symmetry, order 3. Because when I spun it, there were 3 times I got the same shape back. Okay, now looking at my oval.
I bet it's 2.
Yep, so here's my oval. As I spin it, when does it look exactly the same? So if I move it around here, it's not the same yet. It's not the same till here. So it's 1, 2.
Wow.
So it has order 2. I know.
This is unpredictable.
Okay, so that has 2 order 2 of rotational symmetry. Does that make sense to everyone?
Yeah.
Sometimes on a Tuesday.
Okay.
Can we go back to the last page?
We will. This is the last example. Okay. So these ones, I've got a grid. I've got 2 shapes. That's nice, Matthew. We're going to rotate the first one clockwise by 90 degrees. Now we always need a point to rotate it round.
Are we
So
writing
on my
this?
diagram, there is a little red dot.
There is.
Okay, so this is a red dot. I'm going to rotate it around that dot by 90 degrees. Yep.
Always going to be a red dot.
There will always be, it won't necessarily be red, but there will be a point that you have to rotate it
This
around.
is another red dot in the middle
Okay.
of nowhere.
Well, that's for this shape. We're going to get there.
That's
okay?
scary.
Let's just focus on this one.
I don't like it.
So in this one here,
When I got home.
shh, sometimes
Come
it's
on.
easier to think about just rotating one line rather than the whole shape. Nick,
Yep.
pay attention. So this line here that goes straight across, if I rotate it clockwise by 90, so that's
This way.
this way,
It is.
yeah,
On yours, effectively.
so
That
this
way.
way,
Yes.
and I'm going by 90, so instead of here, it's going to go straight up. Is everyone happy with that?
No.
So
No.
this line has
Makes
gone
me
straight
sad.
up there.
No. Oh, darn.
Yes.
Can you
Wait, what?
No, it still has.
might go up.
Why
Okay.
did we face into the left? Yeah,
So
your
we've
shape is
rotated this point here has gone around
Round.
90 degrees.
Okay.
Yep.
Are we moving?
Okay.
Now that means that's the start of the shape here. This line here will now come out here.
Yep.
Yep.
Oh, okay.
Can we see it?
Yeah.
Okay.
So my whole shape has turned around clockwise 90 degrees. Okay? This one here, I want to rotate 180. Why didn't I specify clockwise or anti-clockwise?
Because
You're
it's
aiming
gonna
around
go.
the
Because it doesn't matter.
Because it doesn't matter.
Just go the same way, it'll still be halfway.
Is exactly halfway. So whether you go
Hi guys.
whether you go clockwise or anti-clockwise, it's going to give you exactly the same shape.
Yes.
Okay, so this point here, for example, has to go 180 rounds.
Ooh, clap tense.
So it's going to go to here.
Yes.
Is everyone happy with that?
Yes.
Okay.
Actually, I'm sad for that.
You're sad about that. Okay. Why does that make
So
you
do you-
sad?
So draw the rest of the shape. Wouldn't it go to the right?
This one
Okay,
here
that's obviously the reason.
Wouldn't that
It's
go to
going to
the right?
rotate over here.
Yes, I knew that.
Yes?
Oh, yes, I see.
Can we see where the shape's going to go now?
Yes.
Totally.
And then you just draw it because it'll be the same anyway.
Wait, but oh, the red.
Oh.
Okay, so
Nailed it.
rotated around that point 180 degrees.
I totally get it now.
Okay, your turn to try some. To help you, I've printed the exercise 8C again, so you can draw on it.